because the bases are not the same, we can't do anything with this expression. We can't make it a single logarithm. So what we say is that this is already simplified. So then what we do is we move to the next problem, and we notice we've got a base 3 and a base 3. They're the same. So we can combine these. We know that this 3 is going up here and cubing this whole thing. And we know the minus is dividing. So what we end up having is log base 3 of 16 divided by 2t cubed. Now we have to simplify this, and this ends up being log base 3 of 16 divided by 2 cubed is 8, and then 2 cubed. Now, we always keep going until we can simplify it, and we see that this simplifies to log base 3 of 2 over t cubed. And this ends up being your answer for B. Now, to do the last problem, again, we're looking at the bases. The bases are the same. We know that this number goes in the exponent spot here. This addition means that we are multiplying. So we get log base 12, log base 12 of 16 plus log base 12 of 9. This ends up being log base 12 of 16 times 9. And this ends up being log base 12. 16 times 9 is 144. Now, this can be simplified, and we can say that this is 12 to some power equals 144 is the same thing as 12 squared. So what do we know this whole thing equals? It's going to equals 2. And there we have that simplified. Alright, what we want to do here is we want to figure out what this equals to the nearest thousand. We've been playing this game where we convert it to exponential form, but because we can't write these in the same exponential form, if I look at 5 to the x equals 10 to what power, we can't get these in the same base, so we need another method. And to do this, we can use the change of base formula. And the change of base formula says that this will equal log base 10 of 10 divided by log base 10 of 5. And then we can use our calculator to figure out what this equals. So we do log 10 equals divided by log 5, and we hit enter. And then what we end up getting is 1.43. So this ends up being roughly 1.430, and we round to the nearest thousand. Now the same thing can be done with this problem here, is we can't get them in the same base, so we take the log of 20 divided by the log of 2. And again, we use our calculator, log 20 divided by log 2, enter. And so then we end up getting 4.32. that was what our approximation is. And so this is, again, approximation. This is the exact answer. What we want to do here is we want to express this as a product, and this exponent right here can be put into the front. So what we end up getting is 2 times log base 6 of 36. Now realize 36, we can write that 2 log base 6 of 6 squared, and here we have another exponent. So what happens to this exponent is we can bring it around into the front. So now we have 2 times 2, which is 4 log base 6 of 6. We know that this goes to 1, so then we get 4 times 1, which is 4. And that's what A equals, is 4. Now what we can do is we can do the second problem the same way, and we have negative 2 log 10. Now what you have to remember, we don't have it written in, this is a common log and this is base 10, so we know that this equals 1. So then we get negative 2 times 1. Negative 2 times 1 is negative 2. And that is our answer to 12b. Our last problem, we're doing it the same way. Even though this is a fraction, this is going to be negative 3 times log base 2 of 1 divided by 4. Now, we can change 4's to the second power, and so this is going to be negative 3 log base 2, and this is 1 over 2 squared. And we can put this into the numerator, and what does the exponent become? Negative 3 log base 2 of 2 to the negative 2. So this here can come around into the front, and so then we get negative 2 times negative 3, which is positive 6 times log base 2 of 2. What do we know this goes to? It goes to 1, so 6 times 1 equals 6. And that is our answer to C. What we want to do here is, this is an exponential equation because we have the variable in the exponent spot. So now what I want to do is solve for p. What I notice is 9 and 27 can be written in powers of 3. So I get 3 squared 2p equals 3 cubed and p minus 1. So now what I have done is I've changed these and written them with a base of 3. Now with the base of 3, what I can do is, for this to be an equal statement, the exponents have to equal each other. So then you get 2 times 2p is 4p equals 3 times p minus 1. Now I wrote it this way. You can, if you remember to distribute it, that's fine, but some people forget. Remember, you have to distribute it because you're multiplying by a quantity. So then we get 4p equals 3p minus 3. And then we subtract 3p from both sides, and we get p equals negative 3. And that is your answer. Now, the one thing that you can always do is you should be able to check your answer. So if you insert negative 3 into your answer, it should work. So if you get 9 to 2 times negative 3 equals 27 to the negative 3 and minus 1. So then this ends up being 9 to the negative, what is that, negative 6. And this ends up being 27 to the negative 4. And again, we can play that game of changing the powers. This is 3 squared to the negative 6, which is 3 to the negative 12. And then this ends up being 3 cubed to the negative 4. And so this is 3 to the negative 12 also, and it checks. Now the next problem that we want to do is we want to do the same problem, but we have a little difference. Here we could write the same base, but in this problem, if you notice, the bases aren't the same. I mean, they're both factors of 5, but we can't write them both as 5 squared or 5 cubed. So we need a little different method. And the method that we're going to use here is we're going to take the log of both sides equals log 15. Now the whole reason of doing the log of both sides is we know that this right here can come around down in the front using the properties of logarithms. And so then we end up getting 2x plus 3 times log 5 equals log 15. And what we can do here is we can do a couple things. We can distribute this, so then we get 2x log 5 plus 3 log 5 equals log 15. Then we can subtract, so then we get 2x log 5 equals log 15 minus 3 log 5. Okay, so we're trying to get x by itself, so then what do we have to do? Divide by 2 log 5 on both sides. So then we get x equals log 15 minus 3 log 5, all divided by 2 log. And this is your exact answer. And then you can also put this into your calculator, and you will get an approximation of negative 0.658, and that is your answer, your approximation. Exact answer, approximation.